Welcome, everybody, to Learning with Lowell. I'm your host, Lowell, serial entrepreneur and startup advisor as well. Every week, we discover and speak with expert scientists and leaders from around the world. If you like this type of content, please subscribe and comment. It tells Google gods this is content worth watching. Today, we're joined with Nikolina Lauc, co-founder and CEO of GlycanAge, which is seeking to unlock the human gene glycome for, I'm just so used to reading genome, unlocking the human glycome for preventative health and longevity. Nikolina, welcome to the show.
Thank you for having me here.
Sweet. So the big thing I want to start with is they talk about healthcare and the ability to impact people's lives, and I'm wondering what evidence supports GlycanAge. So what research was done, that type of thing.
Yeah, so it started quite a long time ago. The field is called glycobiology, and it's been around for about 30-something years, so it's a bit of a new field. Of course, this was known 150 years ago, but this is when the field started to progress. And our lab was actually the first lab, together with another glycan lab in Dublin. We were the first lab to look at glycans at scale. So analyze the first 1,000 human glycomes in 2007. And that was the birth of this high-throughput glycomics, which we use for what we do today. And then from evidence and art standpoint, the clock is about 10 years old. The first publication on the clock was 2013. And it was actually published on the same date and year as the first epigenetic clock. So Steve Horvitz, Horvitz clock. And we saw aging from the moment we looked at these few thousands of people. I think we were at 5,000 or 10,000 people. And the strongest signal you can see is aging. And it was some type of aging. Later, we learned that it is, something we call biological age now. And from then, so the last 10 years, we've had about 300 publications in good journals, looking at biobanks, all kinds of clinical studies, intervention studies to validate what we do.
What was able to be known 150 years ago? You said it's like that old. I'm just curious, like 150 years ago, I imagine like leaching is more the thing they were doing. So what were they able to know back then?
No, it was blood groups. So
Okay.
Blood groups are chemically glycans. You have a certain blood group because of the glycans and blood cells. So that was known 150 years ago.
Oh, okay. And then 2007 to now, 300 publications, biobanks, etc. What are the results of some of those things? Like some of the highlights that you'd note that you were surprised by, or that really meant a lot to you and to the company and what you're trying to do?
Well, I think the most exciting thing about the field is the underlying biology, and that's a long conversation. We can go into it, and how everybody's familiar with the genome. Nobody's heard of the glycome, but it's one of the most dense information sets we have in biology. I think highlights of everything is when we had. So if you look at these large longitudinal studies where you have people before they get ill, so when they're healthy, and then you have a follow-up as they develop certain conditions through time. In majority of the conditions we looked at, glycans would alter a decade before you develop symptoms and you're diagnosed with a disease, which means you can preempt it a long time in advance while it's on an early molecular level and do preventative healthcare. So I would say that's the most exciting thing. Then there's a lot of new recent things happening, but they're too early to talk about. But maybe another one I would highlight is gender differences in aging. We can see them very clearly in glycans. Men and women age completely differently. And in women, we can preempt menopause, which is the main aging event. And I think in terms of interventions, probably apart from some drug interventions, different dietary interventions have had a much stronger impact on GlycanAge than, for example, exercise.
For the research populations that you've done your studies on, were they diverse enough where anyone can pick up this and know it'll work for them, or were some populations left out, or Because I think often that usually when there's, clinical research of some kind, it's usually like, guys that do it, or, guys in like Anglo-Saxon descent and that type of thing. So can you talk, it's kind of like a really esoteric, nerdy thing to wonder about, but what's the pie slice in terms of diversity when it comes to the actual research?
Yeah, so it's not, I can't tell you the exact pie slice, but so our chief scientist is co-founder of the Human Glycome Project with another guy from Harvard. And when they started in 2017, was it 17? I think the first official meeting was 17. They recruited 31 different populations around the world, which was very diverse. So it went from different parts in Asia, parts in Africa, Europe, US. They had very nice diversity, over 10,000 people and 31 different populations. So we started with a nice diverse baseline there, and then the larger biobanks like Twins UK, Estonian Biobank, lots of local ones, where you have a decent, even some immigrant biobanks like Zebra cohort in the UK, which is white baseline immigrants, Asian, and Afro-Caribbean, first and second generation. So we do have more diversity than many other biomarkers.
Yeah.
We made a big effort in that. And we also have a very nice gender balance.
Yeah, it sounds like I'm used to reading clinical studies where if you look at the population density, it's like, it's great for people who look like me, but like everyone else who wants to rely on something and know that they can trust it. That's one of the things I always imagine. If I'm going to the hospital and they say, hey, take this drug, you're going to have this type of output from it, and they take it and they realize they're there's personalized medicine, but there's even like just as an ethnicity and stuff, like they weren't even taken into account because population sample and stuff like that, and then you have a different reaction, and then the doctor's like, well, that's not supposed to be happening. It's like, well, it's not supposed to be happening because it wasn't researched and stuff. And I can only imagine the stress and the terror of doctors being like, well, we don't know because we didn't make an effort. So I really love that there was such a large effort to get so much diversity in the research population. It shows like a really robustness to the model.
Thank you. And I think with drug response, it gets even more complicated. Everything we do is experimental. You give a drug and you wait for effect, and if it's good, you continue. If not, you try something else. There's no personalized science behind it yet that you can apply. There's some in genomics on a certain level, but there's so many other things that impact it, from microbiome to epigenetics, that you will never have the perfect prediction in an individual until we do all of that and put all of that together and figure out what works for you. Yeah.
And there's definitely questions later that I want to talk about, like what do all we need. But for now, I'd like to jump into the Glycome. Like, you're right. When I even reading it in the intro, some people were definitely going to make fun of me. Yeah. I started saying the genome because I'm just so used to seeing those letters, and I'm like mildly dyslexic. But from a biological standpoint, what is that uniqueness that you mentioned a minute ago to the Glycome?
Yeah, no, I'm very dyslexic, so don't worry about it. And also, to make you feel better, Carolyn Bertozzi, she won a Nobel Prize last year for her work on using click chemistry to understand what glycans and cell surface do. And this is actually the first Nobel Prize involving glycans. She was in a room of, I don't know how many Nobel laureates, let's say, quite a few. And she asked the question of, in the genome, we have 4 letters. How many letters do we have in the glycome? And no Nobel laureate knew the answer. There's 9 letters in the glycome. So it's a field that's been hugely ignored and not really put into mainstream. There were not even tools to analyze it at scale as we have today. But if you look at a cell, it has 4 components. You have DNA, protein, lipid, and carb. And glycans are the carb part. They're sugars, complex sugars. But when we think of them as sugars, usually people think of things they're familiar with. So you think about glucose. Maybe you think about different dietary sugars. But what we don't realize is that this is also a building block of life, and we manufacture these sugars ourselves within the cell. They become a component of the cell. They're a structural component of majority of our proteins, and they enable our biology to communicate. So there's a sugar language around our cells and our proteins, even our lipids, that enables our biology to communicate. If we didn't have glycans, we would still be single cell bacteria. So it's an evolutionary step that we develop to become multicellular. And it's involved in pretty much everything, but very little of it is actually known. And from what we know, it's quite exciting.
Does it have, the DNA has 4, and yet it can do so much with that. Does it have a lot more, because it has 9 letters, does it have more customization, more capacity to do things because it has more letters? Or sometimes I wonder if you have more but you do less. I think one of the largest genomes that we've studied is one of the stupidest small cells somewhere. I think I was reading that where it's it's not even a complex organism that has one of the largest genomes, and so it's what are you doing with all that extra data? You're just carrying that stuff around. So I just imagine having suitcases of stuff wherever you go. But so what do we get for having 9 letters versus 4 or fewer letters with the Glycome?
So it's magnitudes more complex than the genome, even to analyze. It's very complicated. It's also something that is influenced by genetics. So your glycan composition, and I can talk about antibodies because that's where we specialize it, is quite heritable. So there's a network of, for example, 40 genes which define the different structures on your antibodies. So you inherit it as a complex trait. And then it's also influenced by epigenetics. It's influenced by your environment. And it puts all of that together into something that is a molecule that actively does work in the body. So it's in a way more upstream. In simple, you can think of it as functionality of proteins, or they're technically post-translational modifications, which means they change how your protein works. Proteins work beyond the genetics, epigenetics, incorporating everything else.
That's interesting. Yeah, I always want to. Proteins are that really complex thing that it always strikes me as weird for all the people with PhDs that are listening in. It always feels weird to me that just on how something's shaped. I know this is weird because when you get down to the chemistry of things, a lot of things just in our cells have a specific thing that slots into it and stuff. But I always feel it's such an odd concept that just the fold of a chair would determine its function beyond. I guess that actually makes kind of obvious sense now I said that out loud. But it always feels such an odd concept to me. It's not intuitive that the different folding or how the mechanisms come into it would allow such variability. I'm just I guess I'm used to the macro scale of seeing a tree and all these different things. But I guess form is function.
Yeah, and actually glycans are in these areas where they, for example, define the form of antibodies. They can completely change its form.
Yeah. What interested you in the Glycome? What made you want to dedicate such a large portion of your life and probably your foreseeable future to developing this type of research and intervention type strategies?
So I'm actually a tech engineer as a background. I'm not a biologist. I got into it 5 years ago, and it all came from my father. So our chief scientific officer is my dad, and he founded this. He started in glycan science in 1991 when I was born. So the year I was born, he published his first study in glycans and brain aging. And it was co-authored by my mom, who was a neuroscientist. So it was a little bit of a family history. And he dedicated all of his career to it. He's one of the top experts in the world, one of the top 10 in glycobiology. He did a lot for the field. And he was convincing me for a very long time that this could, we can bring this to people in some way, that we could measure aging, that we can use this for preventive healthcare. And it took me a while to decide to cross over. And I actually didn't think of aging as a disease. I thought it was more of a treating aging was for vanity. It wasn't for health. But then as I understood more and more, I realized, oh, wow, instead of waiting for things to break, you can work on actually what's causing the problem and delay a whole host of issues in the future.
So you have your parents that are the genesis. Where do you see your work influencing how it's going to go for the next couple of years or into the foreseeable future?
Well, first, we managed to put the first product on the market. So GlycanAge is, period, the first glycan product on the market. Actually, no, I'm lying. There is an early liver disease detection diagnostic that went on the market a little while ago, but let's say we're the first in this non-diagnostic application. And later on will be diagnostic. I think there's two roles that we play. One is, how do you create products from this that people can use and benefit from? And that includes clinicians, it includes individuals, bringing it to a point that it's actually useful. Because if I give you a bunch of complex science, what are you going to do with it? And that's how we started. You got a number and a bunch of complex science, and nobody understood what it meant. I think we've gone very far since then. Another one is this translation of the science. Because if you're talking to a glycobiologist, it sounds alien to you. Like it's a completely different, it'll take a while to be able to understand what they're talking about. And finding a language which is easier to translate on different levels of expertise, that we can reach a more broad audience for interest. This is, for example, what happened with the Human Genome Project. It became a PR campaign. And then after CSI Miami, DNA became something everybody knew what it is, or they thought they knew what it is. So I think that's a second role we play.
Mm-hmm. Is there interest to delve deeper, spend some amount of your money on R&D to understand more of the glycome, or do you see yourself more licensing out IP from research institutions that are doing that cutting edge type stuff, and then being the more innovative factor that combines the history that you have, the innovation that you have, as well as the vision for the future?
So we currently invest all of our profits into R&D. And even the commercial analysis funds R&D in the lab, because there's so much to do. Part of it is grant funding. So the Research Institute they do a very little contract analysis. They pretty much have us as the biggest client right now. Everything else is grant and academic research. And whenever there's opportunity, we do a lot of research where we cover the cost, for example, because we want to understand if a certain drug has an impact, or if we can preempt different women's health issues. That's a big area of interest. Mm-hmm. Fertility is a big area of interest. So these are all things that we look at as R&D projects. We don't know if they're going to come up with anything interesting, but somebody has to do it. And the moment, if we can't find other funding, we fund it ourselves.
I think, are you familiar with what SENS is doing with the I think it's a Glycome. They're doing something with similar to this. I think SENS is. One second. It's like one of their new research projects. Are you familiar with SENS?
SENS Aubrey's X Institute.
Yes, I was going to feel like it's not really. It's not a thing anymore.
No, I know.
The one that Lisa was recently on, and they were talking about. I'm trying to pull it up while I'm like talking at the same time, see if I can find where I'm thinking of. I think there's something they're working on that's related to this. But anyways,
that'd be really cool.
Yeah, well, I think that's like one of their new branches is they want to do something on the Glycome. If I'm misremembering this, my apologies, people. And maybe this would be a good parallel partnership, because they do a lot of research into longevity. And I think they're soon going to be looking for grant applications. So, do you see yourself partnering with people like the SENS to do this work, or how do you see? Because if you shoulder all the burden on yourself, that's quite a tall task. So I always wonder, like, how can you diversify the risk and lower your potential to have like not great outcomes by overspending?
So first, most of R&D funding comes from Europe. So the labs had 40 million in European grants in the last 16 years, and that brought us to where we are with the R&D side. We're open to all of the new funding mechanisms. So SENS would definitely be, I have to look at if they're looking at glycans, or a lot of times people also talk about glycation and mix it with glycosylation, which are glycans. Glycation is more damage by simple sugars to proteins, which is a different process. But no, absolutely. If they're in glycans, then we would love to support however we can.
Yeah. What you said earlier that you can potentially detect things 10 years before they become a larger issue, which I'm a big fan of, because I think this, for people who've never been sick, when you go to the hospital, it's like trying to stop someone from falling when they're like an inch off the ground. It takes a lot of work, and it's quite painful for everyone involved. But if you can get in advance, it's relatively much easier to address the problem. So what diseases, aging I would say is a disease, but it's more like a bunch of diseases working together to be jerks. But what do you suspect, or what have you seen so far that could be diseases that this type of research would have an effect on in terms of monitoring personalized medicine or seeing it before it's a bigger problem?
So first we looked at life expectancy and mortality. And then when we saw these are associations, but when we saw that, we focused on what's the biggest killer, and that's cardiovascular disease. So we have a decade of work on cardiovascular disease, where we even mechanistically understand what's going on. So in general, we would see glycans shift a decade before a heart attack or stroke. We also see them shift about 7 years before hypertension. So you can preempt hypertension. And in humans, you can do causal studies, but you can do them in mice. So we had a mice trial where you feed mice a high-fat diet, they become obese, they develop hypertension. But if you give them a certain glycan, like a precursor to a glycan structure, you get obese mice, which don't become hypertensive. So there's a causal, at least in the case of obesity-induced hypertension.
Yeah. Are you partnering with research organizations that are looking for interventions, or are you going to make this like the brain that you can develop interventions yourself?
So we try to get into any longevity trial that's going on. So any new drug development, any nutraceutical. If we have a connection, we'll try and join the trial and see if there's an effect on glycans. There's, of course, interventions that we already now know work in animal models, but these are still, we're waiting for a publication probably for the next year. It takes on average 6 months to a year until something gets published. So I can tell you more about that then. And that's something that we're working to co-develop with the researchers to help them more, to dig deeper in what's going on in the therapy, but we don't do drug development ourselves. We would do basic research that supports it, and then somebody else will go and develop the drugs.
Yeah. Is there anything that it's not suited for someone who's, still learning about the glycome? Are there things that people would wrongly attribute to be something they could track with the glycome? Like sort of questions that you get that you notice that are incorrect in terms of assumptions that people can use it for?
Well, the biggest incorrect assumption is that glycans are the same thing as, for example, HbA1c, or that this is something you can impact by how much sugar you eat. Nothing to do with it. These are sugars you manufacture yourself. So they develop together doing protein synthesis. They're a structural component of the protein. You can't just eat a low sugar diet or high. Yes, of course, diet will have an impact on it, but it's not a direct impact of the dietary sugar you're eating. So that's one. Another one would maybe be if you're, so what we're really looking at GlycanAge is your adaptive immune system, antibodies. And those is glycoproteins, or the glycans in your antibodies. And that is a reflection of aging of the immune system. And then as the immune system ages, it's underactive in some areas, overactive in others. So you get this baseline low-level chronic inflammation. So it's an aging clock. Or you have an underactive immune system, which, for example, doesn't tackle cancer or an infection well. So that's what we're looking at. And a lot of times people think that this is also something you can measure aging in children. And we actually see that because their immune system is still developing, they're quite pro-inflammatory when they're young. Only as they hit puberty does it stabilize, and then aging begins on that side, at least from what we're looking at on the long-term side. So that's one. Can I test my son who's 13? No, don't do it. Well, there are some specific signatures. For example, juvenile arthritis. And that's something where there can be a nice glycan diagnostic, and it's also preemptive. In rheumatoid, glycans also alter a decade before symptoms and a diagnosis. The problem is we don't have a lot of interventions for prevention, so you're more just preempting it.
Mm-hmm.
And then anything else, I don't think I can think of, because it would respond to most things you do. So anything you're going through in life, any therapy or any intervention you're trying, you're going to see an effect if it has an effect on you. If it doesn't, you're not going to see any effect.
Yeah. So kids don't put it there. Are there any differences if like compared to like the 20s, 30s, 40s, 50s, 60s? Is there a population in terms of age where the glycome really changes, or like there's a really unique deviation from what would be normal?
Well, just in women around menopause. So men are very linear. So post-puberty, they just go up in a straight line. That was so boring, but in terms of cardioglycan markers, they're more complex than women. Women are very simple in cardiomarkers. They have one structure, which is very predictive. In men, it's a whole host of different structures. But in terms of aging, they're linear. Women would generally look more favorable to men pre-menopause, and then as they go into perimenopause, so their hormones start to decline, they have this accelerated rate of aging. We see that it's more than double than what it would usually be, and then they catch up with men and they move together with them. So that's.
If a woman never had menopause, do you think that women would just naturally? Well, I mean, it seems like women typically last longer than men in terms of aging. But if they could just skip menopause or something, or damp it down and not have these negative effects, do you expect like women would just all live to like 100 or something? Like, what would be the effects of? Every woman I've known who's gone through menopause did not enjoy the experience. They were, but so if they could skip it, other than just like the negative experience you're missing, would there be other health benefits that you would see, or that you would suspect that you'd see?
Well, most chronic conditions in women, they develop post-menopause, or that's where you have the biggest, it's like an inflection point for women's health that leads them more towards disease. It would have a massive effect on health span. I'm not sure I can tell you how much, but I would say it would be pretty significant, maybe if I speculate a decade or two, but we don't know until somebody tries to do that, and there's not many solutions for it because women run out of eggs.
That's fair.
Yeah.
So there's no like, as a woman, you don't have any like pet theories or ideas for correcting that type of thing, or is it just something to be aware of, and then when you see that change, to maybe have some personalized medicine or preventions interjecting at that point to correct them? Is it kind of like just like a sunk cost, like it'll happen, so then just account for it and have interventions help for it?
Well, we do see HRT has a significant impact, and it would impact your GlycanAge as well, positively in most cases, and we see some negative markers sometimes go up in a small, so it's something that should be personalized medicine, and there'll be better and better tools to do that properly. But even with HRT, you do have 14% reduction in all-cause mortality. You have a 26% reduction in diabetes and many other conditions. So it's a known positive health span effect. But I think what that field is searching, there's been a lot of misconceptions around it and some bad science in the past, but there's definitely space for precision medicine with HRT. But the problem with HRT is you're still losing fertility. And the biggest issue with women is actually just loss of fertility. That happens far faster than it happens in men. It happens with, well, pretty much, I don't want to, but from 35, you're in the lower reserve, and then by the time you get to menopause, you have maybe 1,000 eggs left from 1 million that you had when you were born, and maybe about 300,000 by the time you hit puberty. And it's men have lifelong production, so you don't have the same complications. So when you look at this record holders, the oldest man who had a child naturally was 92. The oldest woman who had a child naturally was 57. So it's a huge gap. So what the field is looking to fix there is to preserve, ovarian function, but also ovarian reserve. And you have a few exciting companies working on that that are targeting AMH, which is this hormone that it's like a proxy for ovarian reserve. And it's now assumed that if you suppress it, it could stop the release of eggs within a month. So you keep your ovarian, and it could potentially even be a contraceptive. So instead of what's done today, where you're making the body think it's pregnant as a contraceptive and you're still losing your egg reserve, it could be something that stops this release of eggs. And by maybe you start in your 20s, by the time you get in your 30s, you have your egg reserve or a 20-year-old. Now, we don't know if there's going to be a difference if you're in your 40s or in the whole body ages as well. And we don't know how that impacts it, but it would fix the problem of loss of eggs, which could be exciting.
Why is it that when we're developing up to like puberty that we see such a precipitous loss of eggs, or even our neurons? We have like a ton of neurons and we lose a huge amount of it. I was wondering, why is that? Why is it that we start with so much and then it reduces by half or more over the course of 10 years? And then it's like, well, I'll be happy with that. And then we refine from there. It seems kind of weird to me. It's like we're over-engineered or something. I don't know why that is. Why would we start with 1 million and then lose 70% over the course of your first like you're not doing anything with them at that time, I think. I don't know. But why do they just die? Or is it like the body's like testing them or something and these are like the bad ones? It's like we have a 70% success rate for healthy eggs. Why is this? Why does this exist? Why does this happen?
I have no idea. And I don't know if we know the answer yet, but it's a
weird.
good question.
Yeah. Is there any reason why men would have more complex cardiomarkers? Like why? You mentioned that earlier. I was like, oh, why do we get that? Yeah.
We don't know. We have no idea just yet. But there's definitely, we definitely know that there's a big gender difference in well, at least by looking at glycans, how you develop cardiovascular disease. When we know, I'll let you know if we find out. But
yeah, it's just yeah. Well, I was just wondering because men have a higher rate of cardiovascular disease, so I wonder if that'd be something related to it. I don't know why these things exist for the gender differences, but it seems like in studying them we can understand each other. It's like what happens to a woman and how it affects. It could, like, I think I was recently talking to Jennifer Garrison, and she said, if you want to know how long you'll live as a man in terms of longevity, if you have a sister, look at when she has menopause, because there's a strong correlation with that determining like how long you'll live. So if she has it really early, you might not be long for the world, but if she has it later, it means you probably you'll last a little longer, which is kind of interesting. They have like a longer lifespan.
Well, the genetics play a part, but beyond whatever genetics you're born with, we know you can get an extra 13-50 years of healthy life with lifestyle modifications. So there's a lot you can do no matter what that. And of course, there's a lot you can do to decrease a big timeline if you've been given one. So it can go in both directions.
Yeah. Is there any thought about getting this insured under insurance so people can just, when their yearly checkup, the doctor says like, here, take this, this sampling of tests, and we have just even if it's like local or something, I don't know. Is that something that you can do in the EU? Because you guys, I think I'm in the US, so I'm just used to like insurance being obnoxious, which may be harder to do. But in the EU, I think that maybe it'd be even more obnoxious. I don't know. But is that something that you can do? Is this something an avenue that you do see yourself going down to like partner with clinicians, get it insured so that it's easier for people to access?
So EU is complicated because you usually work country to country with local healthcare systems. We're looking at it in the Middle East. So that could be an early adopter. They're very early in adopting a lot of new technologies. They don't have the burden of worrying about health economics. Because if you, for example, want to go into the NHS, you have to prove that your solution is going to save the healthcare system money, which is a very large, expensive trial for a young company. You generally can't go there until much later on. But in the Middle East, it's a little bit different. Of course, there should be some cost benefit in terms of reducing disease, but they're not as reliant on that system as Europe is. And US can be as well. The issue with the US is we're trying to get to the point where aging is considered a disease, so you can treat it, which I think there's some movement in getting close to that, but aging is still not seen as a disease. So technically you can't treat it yet under healthcare. What we're looking at for that is developing specific diagnostic markers. Because when we're looking at aging, it's not a diagnostic. Getting into healthcare is more tricky. You're mainly you can get into private healthcare, but it's cash pay. It's not going to be reimbursed by insurance. But as we go more towards specific conditions, and you can't go with many. So for example, what we look at in GlycanAge, we just published a large review paper that looked at all of our work, all of the work from other labs around the world. And today it's been associated with 72 different diseases where we either have, glycans have predictive, prognostic, and diagnostic power. Now, of the 72, you can select one or maybe a group like autoimmunity, and then go with that to FDA as a diagnostic. So that's something we have in our pipeline, and it takes time and it's big trials, but eventually we could have a marker for predicting. I think maybe autoimmunity or perimenopause could be the most interesting ones.
But it sounds like Dubai in the Middle East is like definitely might be like an early adopter of what you're working on, make it a little easier for you. Yeah. How often would you want to do an analysis like this? Is it something that you do quarterly, or is it just 1 year health checkup? Like how often would you want the sampling data to make sure you can have a good understanding of a person?
So it depends on where you are in life and what you're doing. So if you look at the half-life is above 21 days. So you wouldn't really, you would wait. If we're doing a study, we would do at least 6 to 8 weeks minimum post-intervention. 3 months is even more recommended because it doesn't change much. Actually, on average, if you look at people, they age a year per year by their Glycome or GlycanAge. But if they do a change, so lifestyle change intervention, you can see effect of that after 3 months. In other interventions, if they're very gradual, maybe you can wait a bit longer and you might see an effect in 6 months. If you're going through a health change or something new is happening in your life, you can measure how that's having an effect on you, if it's having a negative effect or if you're doing just fine. So it depends on what I would recommend. If there's nothing specifically that you're doing in terms of a new health intervention, you can measure once a year, maybe twice a year maximum. If you're doing a specific intervention, check in after 3 months, see how you've done. If there's a positive change, continue the behavior for another half a year, and then check into it again. I can tell you my example. I've had lots of negative changes in the last year, and I could measure every few months, how negatively it's changing. So I would want to check in as often as I could.
Yeah. And then in checking in, you can, hopefully course correct to make things better.
Yeah.
Yeah.
If your circumstances allow it.
Yes. Yeah. Are you familiar with Bryan Johnson's Blueprint?
Yes, I haven't studied it in detail, but of course he's made it.
Yeah. What for biohackers and for people who want to be on the cutting edge and figure out, like a DIY equivalent of this, where they do something like yours and like a couple other tools to replicate his. I think he spends like $2 million a year. So I think take his and like maybe make it like for the everyman version. So taking something like yours once a year, what other things would you want people to take to have a complete that you think people should be in the buffet of understanding their aging and their health for their own benefit? If they were just biohackers and they just want to pay out of pocket, don't worry about insurance. What all tools and resources do you think they should be using? And then I guess like trying to replicate the blueprint from Bryan Johnson at the same time. See if that's something that the average person can do.
Yeah, I think you can overdo metrics as well. It becomes a bit of an obsession, and sometimes that is not as healthy. But I admire what he's doing. They're putting a big effort and definitely changing a lot of opinions around it. I would rather recommend doing intervention by intervention. So you decouple the effect and you see, how much is one thing adding or taking away instead of doing everything at once. I don't think there's a good reason to do all of these things at once. You can introduce them much more gradually. And I forgot your question. I'm sorry. It's been
no worries. It's we're having an 8-hour difference here. So Nikolina's been very patient with her time. Basically, part one, how would you replicate that type of thing? And the blueprint. It sounds like you would gradually do it, pick an area and affecting your longevity and health span, and then slowly move in so you don't have compounding effects. So you don't know you're doing like you're doing two things that actually are doing roughly the same thing. So that's part one. And then there was part two, but I'd love to dive down into that. What if you were to do it for yourself? If you were to replicate this, what would that strategy look like? And it's not advice for anyone else. I'm just kind of curious.
Yeah.
What tests would you be taking? What metrics would you take? And then like as you get those baselines, what would be your next steps and that type of thing?
Well, I think that will also be quite individual. What we can do now from your Glycome is not just give you an age, but we can preempt where you might be headed. And, we can't tell you diseases, but we could say it's gut health, it's an overactive immune system, it's heart health, so forth. So you can metabolic health, so you can know. And from there, you have a different panel of things you would do, different panel of interventions for gut health, different panel of different diagnostic tests you would do, some for autoimmunity, others for example, early colonoscopy and so forth. So it's always individual. And I, what I've done myself, I've measured everything that I thought was worth measuring. So you start from the genome, you see what you're born with, if you can identify some inherent risks, and then you do all of the regular blood works which are available to you. You see if there's anything that's specific to you. You try to understand if it's genetic, like I metabolize iron much better. That's genetic. It's from my grandfather's side. And then you look at if you can identify what risk something might have in the future. Like I would measure specific things for me, which would be hormones, because I have there's no genetic test for it, but an inherent risk for PCOS. So I would always measure that, and that's a risk for diabetes, and that is something I also have in the family. So I would find things that matter to me, and then measure those. There will never be one for every. Somebody might have a lot of family history of cancer, or a lot of predisposition that they already know, and then maybe a full body MRI would be recommended, or different early cancer screening. It will always be, there's never going to be one that's going to be important for everybody.
Yeah, I always wonder when you see a doctor, is there a way to get your eyes on all the major areas? So you have the blood and blood pressure and that type of thing that usually is done at the time. But then I also wonder, are there other things that could cover other areas like the gut health, et cetera, that you just mentioned? And then what other areas are typically, something that maybe is not a concern, but good to like keep an eye on because like the risks of it. Maybe if you're like outdoors all the time in the summer, maybe something to keep an eye on, skin cancer, for instance. But so is there, so you can have like the eyes on the largest percentage before it gets to the point where it's not usable, to keep track of your health and intervene accordingly. Like last year, my doctor was like, "You have high cholesterol. Lose weight or take a pill." And I was like, "I'll lose weight. That's easier. I'm squishy anyway. That works out." So that type of thing. So I wonder with what we have now, what could we do next with products like yours to get as big of a sense of where your health is without going to the point where you're like over metricizing and finding like false positives.
Yeah, well, different products play a different role. Ours is less frequency, more value for long-term health outcomes. So you do a intervention, you check in with this in 3 months or in 6 months, you see, okay, this, if you see a positive change or reduction in your GlycanAge, and you can really reduce your GlycanAge. We see that on average, if you're going to talk about world records, our average successful user reduces 5.4 glycan years in a year. And then sometimes they get better than that. Sometimes they get those years back because they go back to old behaviors. So it's usually we see there's a very good 6 months effect, and then sometimes we tend to go back to some old habits. So, see, my brain's stopping functioning. Yeah, I'm missing some sleep. Another thing, so on what we do, in a few months, you have feedback if you're going to have a long-term outcome. Another thing is you need daily feedback. And for example, diet is something you would want to check into on something that gives you daily feedback. And you have a number of different companies. One is Zoe. We just did a large study with them, which does like a 2-week, like it started as a science, not experiment, but like a research study where they give you this protocol for 2 weeks where you wear a glucose monitor, you look at your individual response to, they give you muffins which are high in fat or high in carbs, so you see how you individually respond to that, and then they look at microbiome and a number of different things, and then from there you can get they run this machine learning which tells you what foods work better or worse for you, and then you follow that and you follow your symptoms, you follow progress and fix your diet without following some kind of generic confusing advice. Because I think in terms of nutrition, there's so much contradicting advice everywhere. And that's because we're so unique and individual. And just because something's like a vegan diet is working for somebody, it might actually be causing you harm if you have a different, you have a different response to it. So these are things you will measure more frequently. Also, sleep. These wearables are super useful. They would give you feedback on, if you have a meal too late, you're going to be able to see it in your sleep. You have a glass of wine, you're going to be able to see it in your sleep. You're not going to feel any different the next day, but if you look at your metrics on the wearables, they will be different. So it gives you feedback on a daily basis. Hey, you're doing damage here, or you're doing quite well. So I would say those. And then there's some early screening tests that, depending on if you need them or not, but a lot of times the recommendation for them is way too late. So for example, with the colonoscopy, it's recommended, it depends market to market, but it's pretty much 50 plus. But in some people already in their 30s and 40s, they've already got to it. So it should be something that's identified that you can prevent if you do early screening. And of course, a lot of these early screenings are not so enjoyable to do, but if you identify your risks and then you do them, then they're definitely worthwhile in the long run.
Yeah, the food one, this is the first time hearing about Zoe, and that sounds really cool, because I always wonder, is there a way to eat optimally? Because I don't eat a lot, but I always wonder, am I eating the right things? And you read the internet and it's like everyone has a theory like eat aluminum. I don't know. It's like it's all equally valid in terms of I don't know what I'm supposed to be eating, but that'd be pretty interesting. For your thing, what is the benefit of getting a 5-point difference? Like if I used your product and I did an intervention, what would I feel like? What would be the outcome of that type of difference? Is it just like something that's a number, or would I actually like have an improvement in my life? Like what I feel that?
So we don't, so some things we know, some things we don't know. And there's been 1,000 people multi-omic study, Arcadis, it's a biobank with Edinburgh University, that looked at all the different aging clocks in 1,000 people at baseline. And then they had a 10-year follow-up. And it looked at if you had an accelerated aging clock, and whichever of the ones was a predictive of hospitalization. And there, an aging or a GlycanAge that was above your age was most predictive of the broadest scale of reasons people were hospitalized in 10 years. So we know it's meaningful. We don't yet know how meaningful in an individual. We don't know if it's going to be a year for a year, or if 5 years are going to be worth 1 year. Might never be as specific, but we do know that you will have a better outcome if you reduce some, if you have a higher score, if you can get it to normal, or if you can get it to under normal. Actually, we know that the average good is 10 years under your age. That's the average good. And the average bad is 10 years over your age. So even if you're close to your age, there's a lot of room for improvement.
How do you influence it? Because you mentioned earlier that diet doesn't do diet doesn't do that much to it. So then how do you influence it? You get this data, and then what do you do?
Diet does quite a lot.
Oh, okay. Maybe you meant sugar, because we make our own sugar. I think that's probably what I'm remembering.
So it's not something directly impacted by the sugar you eat in your diet. It's more complex. There's some people which are very good carb metabolizers. We had a study of 1,000 people on 5 different diets, and one of them was a high carb diet. And even in that cohort, you had people who benefited from the diet. And it was actually about half of the cohort sees benefit, half of the cohort sees harm. So there's no bad, the protein is not inherently good, carbs are not inherently good or bad, fat is not inherently good or bad, and so forth. It's all about what's going to work for you as an individual. We see that, for example, caloric restriction is really effective, weight loss as well. We did 700 people on 800 calories for 8 weeks. They saw quite a significant reduction in their GlycanAge. I forgot the exact number, but if I'm not wrong, it was 4 to 5 years, which was pretty extensive in 8 weeks. It's much more than you would see on the epigenetic aging clocks. Then weight loss. We did weight loss as something we followed longitudinally in the twins cohort. So twins who gain weight, twins who lose weight, and the twins who lose weight, they age slower. The twins who gain weight, they age quicker. We also did a cohort with bariatric surgery. And because there's an extensive weight loss, we saw an average of 9 years reduction after 6 months. Not that I would recommend it. It's just a validation that weight loss is really important, however you get to there. There is one caveat to that, and that's exercise. So we did a bunch of different studies. One was big. We're just about getting it published because originally the funders didn't like the outcome. Majority of the gym people in their 40s and 60s, between 40 and 60, going to the gym for the very first time on an intense exercise program, they actually saw accelerated aging. But we did see some of their glycan cardiomarkers go backwards. So they were creating chronic inflammation and inflammaging, but some of the cardio inflammation was reducing. So it wasn't as straightforward. HIIT training had an effect, sprint training in a group of young men. They're all 35. They saw a reduction after 12 weeks. But what we generally see is negative if you do an intense diet and exercise at the same time. In a way, I know this is how the industry is, in a way, that these two things you should do together, otherwise you won't have the outcome you want. But actually, that might be false, and that's something that we need to wait a little bit for more evidence. But if you think of it in a energy standpoint, first you're making your body build new muscle, so it needs extra energy, and then you're depriving it of the energy by starving it at the same time.
Yeah.
So you're burning the candle at both ends, and that's when we often see GlycanAge go up with gradual weight loss over time, not just a tense, 3-month gym. Because my theory is gyms have a big spike of signups in January for about 3 months. They make about 40% of their annual revenue in the first 3 months of the year. And then people keep their membership and they keep paying, but they stop going. And my theory is they put a lot of effort in those 3 months. They overstress themselves physically. They combine these two things together, and then their body tells them, please stop doing this to yourself. But, they keep guilt tripping you, so you keep paying the membership. So I think some of our theories of, how you achieve certain things and what's healthy could end up being wrong in the long run. What we see with diet is that if you see a positive effect, we generally just see a positive effect. There's not like an up and down. And we have clinical evidence for microbiome transplants in colitis patients, and their glycome becomes younger with transplants from a healthy donor into somebody with a condition. So technically, anything that's a successful gut health intervention could have an impact. And we see a lot of individuals just optimize for diversity and not necessarily taking out meat or becoming vegan, but optimizing locally sourced plants seems to, in individuals, not in the study, have a significant impact on GlycanAge.
Okay, so working from back to forward, are there steps in weight loss that have where you see the effect? Or basically, is it like every 5 pounds, every 10 pounds that you start seeing a noticeable effect on what you're measuring? Or I guess it's starting there. Like how is it?
So it's always going to be individual.
Yeah.
But in this 800 calories a day, they lost 10 kilograms in 8 weeks, which is extensive. And
what's
that's
a kilogram?
I'm
an American.
Oh no, I wouldn't know how to do the conversion off the top of my head.
A gallon of milk is how many kilograms? I don't know how much that is in pounds. Okay, a gallon of water. How much is that? I don't know. I'll Google this later.
It's a kilogram. Okay, we look at this later.
So it's like 10 to 15 pounds.
Let's see. Should we do a little Google search and then we find out?
Yeah, no, I feel bad for everybody. Everyone's like this dumb American. Kilogram.
No, I am just as bad as on the other side.
Oh, for 1 kilogram is 2 pounds. So if it's 10, it's 20 pounds. Wow, that's pretty significant, but achievable depending on your weight stuff.
Yeah, no, everybody was overweight in that cohort.
You can survive off of 800 calories. I always felt like your body doesn't need like more or something.
You're not going to enjoy it. No, you're not going to have a good time. And usually nobody can maintain that behavior. You can do it for 8 weeks, and but it's not something you can maintain. So it's not a long term. It's a nice proof of concept that weight loss works even in a short effect, purely positively. But yes, they went on maintenance diets afterwards, and most of them just go back to their baseline by the end of the maintenance diets.
Yeah, I was going to ask, like, does your body get pissed off? And then when you start going back to 15 to 2,000 calories, depending on your stuff, does it just start absorbing it back in, angry that you just starved it? But it sounds like that is what will happen.
No, that's exactly what happens. And this is why the whole personalized diet industry is being developed. And I think that's going to change the way we think about weight loss, because the short-term solutions are definitely not serving us.
Yeah. And then, so intense diet, is that 800 calories, or did you mean that in a different way?
Intense diet, well, it does need to be 800 calories, but what we studied was the 800, but I'm sure that less than that is also effective. Oh, more than that would be good.
Yeah. No, I didn't know if it meant also like, only eating carrots and seeing if you turn orange. But I mean, like, was there other things to the intense factor other than just eating 800 calories?
No, I think it was pure caloric restriction. So no changes in diet apart from how many calories. And then the other part was maintenance diet. So everybody going on different nutrient proportion. And that's where we saw that people are true individual for you to, or there is no one diet that had a significant effect on its own, but individuals, they respond really well to, high carb or high protein.
Okay. Yeah. And then, so we talked about male and female. Does any of this data change for people who are transgender? Like, has that population been studied? I think when they go through the transgendering, there's a lot of hormone. I'm not a scientist. I just know stuff changes. So like, do they stay? How does that affect all these types of numbers?
So we don't have a cohort like that, but we do have hormone replacement in men and women, and it has a significant effect on your glycome, and it's actually even the estrogen that has an effect in men. So if men, this was an intervention study, they suppress testosterone in men. If they give them testosterone replacement on its own, they see their glycans change pro-inflammatory or negatively. But when you give them replacement, they go back to their baseline. So they go back to the healthy baseline. But if you give them replacement plus an aromatase inhibitor, which blocks the conversion into estrogen, then they don't see a positive change. They stay pro-inflammatory. So it's actually even the estrogen in men that has an impact. And there could probably, and I think there's so much that's not well studied or known, but a lot of times, well, men also do have a certain amount of estrogen, and if they're on these blockers and they have no estrogen production, that would definitely be bad for your GlycanAge.
So A, definitely needs more research into that, and then B, there might be some complications where they have to like do the interventions of the, I don't know the term for this, but like becoming transgendering. I don't know if like that's the proper terminology, but
transition maybe.
Thank you. Sure. Yeah, that feels like it's probably more right for people listening. I apologize. I'm trying to understand there might just need like some finessing so that you don't have any downsides.
Yes, I think that medicine is what it is at the moment, and it's very experimental. Even if you're not doing such a thing, if you're just looking for the right drug for you, a lot of times you just get given something that we assume is going to work, and then they measure how you respond to it. So I think that's also what's happening on that side, and there's a lot of trial and error.
Yeah, I think the technology has really come a far way compared to like even at the founding of America, for instance, which good for us. We left the UK and prospered because of it. But anyway, so which is a comment I always make to people in the UK. But our first president, George Washington, he died from being leached. They thought that was an appropriate intervention strategy. And then the last 100 years has basically been like a cookie cutter. You either fit the cookie cutter, or we chop off parts of you that doesn't make sense for the interventions. And now we're getting to the point where it's going to be really personalized, which is really fantastic because everyone is different, which is weird. There's 8 billion people, but I think I read somewhere where the genetic difference between, like, let's say me and you is not that big compared to other animals, which suggests that like at certain points in our history, we were down to like a very small population that rebounded a bunch of times. But it's just so wild that we can have such variability in how we operate.
Yes. And the other problem is that we put so much emphasis on the genome of how we're going to understand the full picture of biology if we analyze the full genome. Now, if we, and none of that's actually fulfilled its promise. I think what we learn is that biology is far more complex. And actually, even we thought that most of our genome codes for proteins, and actually majority of our genome doesn't code for proteins. It does something else. We don't know what it does. And then all of these other layers on top of it, we're never going to get to personalized medicine until we understand all of it. And actually, glycans will play a huge role because they're the most dense information set. They incorporate a person's genetics, epigenetics, environmental influences, and you can tell, you can see if somebody's responding to something or not, or how their health is progressing through time as an individual. So I think this will be a game changer for personalized medicine, but there's so much work to be done until you can get to that stage.
Are there areas or avenues in the Glycome that you're looking to explore? I'm not trying to like hedge around and hear like the upcoming stuff that you don't want to talk about, but are there known unknowns that you're excited to explore?
Well, the first thing is there's only methodologies to look at a certain amount of glycoproteins. And most proteins are actually glycoproteins. So there's some which the methodologies haven't even been developed for us to be able to look at them as glycoproteins. We of course have to build on what we've already done. Going into a completely new area is a big shift. But one thing we're excited about is the fertility, or understand, because that there's been a lot more done work there for men than women. For example, we know that conception is enabled by glycans. So you would have these very anti-inflammatory structure called sialic acid, which coats sperm and enable it to evade the female's immune system to reach the egg. Otherwise, there'll be no conception. And there's been work done there, but very little has been done on oocytes or women's eggs. And that's something that's never been looked at. We don't even know if we can yet, if they're big enough for us to analyze the glycans on them. But that's something we're going to give a go. That's an experimental side that we are working on a new methodology for.
Just a quick interjection. I'd love to hear the rest of why would the female equivalent, because I thought the sperm is much smaller, and yet we know that. Why wouldn't the female egg be studyable in the way that you're talking about?
First issue is it's also precious resource, which is hard to get hold of. So there's one there. And then there's a few more technical bits to it. We didn't do the work. Well, we actually did one paper in that. It was a collaborative study. It's also the type of structures that are easier to analyze versus something that's a little bit harder.
Okay. Yeah. All right. Makes sense. And then what are some of the other areas? I interrupted you.
So women's health is a big focus for us, menopause particularly, but also understanding if we can see, if this is a process which is also somehow involved in fertility, because we do see changes before menopause or in the early perimenopause or in perimenopause. So we're doing some work there to understand if this has anything to do with fertility, because if you're talking about longevity, men and women have completely different problems. For men is you do have a shorter lifespan, you do develop conditions much earlier than women, but women lose fertility much earlier. So if you're talking to women about longevity, what they care about is fertility and how am I going to get through menopause? Or how can I, not have such a horrible time? Or it's been talked about a little bit more. So that's an area we're excited about and that we're focusing on. Apart from that, autoimmunity. So we have a lot of predictive capability in autoimmune conditions, and they're some of the hardest to diagnose. So diagnosis can take a very long time, sometimes more than a decade. A lot of times there's a misdiagnosis, and then the treatment protocols are also not personalized, or there's a lot of trial in there. So that's an area we focus on as well. And then on the longevity side, all of these different, there are some interventions that we evaluated that are not published yet that we saw a very significant effect. And so we would want to, it's been done in rats, we would want to move this forward to dogs to see if we can make also, we wouldn't be doing the intervention, we would be developing the glycan clock to measure it in a study. And then from there, racehorses, which would be a very nice, because if we can do it in dogs, we can do it in rats, do it in dogs, and then in horses, then definitely people will start to believe that we can do this in people. And this is a therapy you can do you can develop with pet animals, but for people you need a drug that can be consumed at mass.
If a dog is a man's best friend, or a horse is a woman's best friend, because I wonder what the female equivalent is, because if it's not dog, I always hear horses or cat. Maybe it's cats. Yeah. I don't know.
Maybe it's cats. I would bet for cats, actually.
Cats feels right. Is there, with your vision going forward, is there anything that you need help with? Is there, are you looking for a member of your team? Are you looking for anyone listening? Maybe there's something they can do to help.
Well, ideally, I would love to find a popular science writer who wants to write about glycans. We don't have a single popular science book literature in this space. Probably our website is one of the largest sources of, simplified information on glycans as you can find. So if you come across a good popular science writer and we can help get him interested in or her in glycans, that would be a big shift for our field.
Well, I feel like if you were to get ChatGPT, the fourth one, and then give it an outline of the data and say, write this like Chaucer, that you're probably done in an hour. That might, I don't know to the extent you want to do something like that, but I feel like that might be a short circuit way to do it just yourself. Do you see AI, ChatGPT, that type of thing, machine learning impacting your work, or is that something that you're actually incorporating, or that you're looking to see if you can incorporate?
So that's actually a good tip. We'll try it. I'll let you know if it comes out in the
forward. Thank Lowell Thompson, and it's like, oh, thanks Lowell for this idea. You can even have the AI thank me. You don't have to do any work.
Yeah.
Yeah.
So we are exploring like an evidence-based AI to give actionable advice combined with personal predispositions, risks, and see if we can make this smarter over time. It's not something we started working on, but it's part of our pipeline. Apart from that, the key problem is this field of biology hasn't been fully explored. So until you've actually extracted the data and done basic research to understand what's actually happening, what do these glycans do, what does it mean, there's very little you can do with AI. So we're still focused on our core because everybody else is going with the hype. Eventually glycans will come to hype, and then there'll be everybody interested in glycans. But we're yet to, we're waiting for that thing.
Would there be a benefit to like a human Gycmome project?
Well, we have one. So our chief scientific officer co-founded the Human Glycome Project. It started in 2017.
Yeah, but it's not like done. So then there's like work in progress.
Not just it's work in progress. So there's an analogy they use, which was if sequencing the human genome was like going to the moon, then analyzing the full human glycome is like going to Mars. It's not possible today. It's completely impossible. But if we can move enough people to do it, we might get there.
What makes it not possible? Is it the financial component? Like what all needs to happen? I'll title this the Human Glycome Project and get people excited for it. What all needs to come together to make the Human Glycome Project not only work but finish? Let's say in the next 5 years. I don't know. We give it before the end of 2030s. What do we need to do to make that happen?
That would be a good question for the founders and the group, so I can pass it on and let you know what answers I get back.
Yeah, they're great. But we'll because if it's one of those big projects, I love that type of stuff. Yeah,
I'll give you a list of things.
Yes, and then I'll put that in the show notes. So, what advice for people who want to get into this, like not in a mean way, but like a relatively unknown element of biology that has such a huge potential? What advice do you have people who are 25, 35 are starting to develop some skills that could be useful to get in and actually, A, find unique stuff like this, but B, maybe even help in some aspect of it? What advice would you give people 25 to 35, which also happens to be most of the people who listen, that age grouping? So like this is great for people listening.
Yeah. So it's a space that if you get in there, you can do a lot of important work. In a lot of other areas, you might just be replicating somebody else's experiments. In this case, you'll be the first to do something. So on that side, it's very exciting, apart from just being an incredibly complex and interesting side of biology. So our research institute has 60 scientists now. 35 of them got their PhD in the institute. So if you're working, if that's a field of interest, there's always the lab is based in Croatia, so it does appeal usually to, but people are traveling from further and further to come and work in the lab.
Mhm.
And then there's a lot of exciting things happening around this in the US around Carolyn Bertozzi. So she's definitely created a movement, and that's more oncology focused, and it is a radical shift in how accurately we can detect cancer early. So and there's some exciting companies. So she co-founded one called Intervene. They're in San Francisco. They're moving towards, they already have markers on the CLIA certified laboratory developed tests for different whole spectrum of different cancers. So finding exciting startups you can join who are working on this area. And then for some reason, which is probably because the healthcare system is different, it's more preventative, China is doing a lot of work in glycomics. There's more and more good papers coming out of China, even for aging. So that's a unique opportunity where they're moving quite fast and they're focused in the field.
Are there any skill sets that would be surprising that would be useful in this field? In the sense of science makes sense if you have a PhD, machine learning, from what you said. Is there anything, so when you look at what you're trying to do, is there a skill set that's rare or a type of person that's rare that would actually make a big impact? Because more often people think I'm not a scientist, I can't do anything. But so I always try to find what things out there that are for non-scientists, or something, or skill sets that you find quite valuable.
There's always a lack of data analysts. And it is a complex space, but you can learn and it's a space where also you can do a lot of building work that others will build on top of, because there's only so many methodologies developed today. So if you're a techie who wants to get into bio, this could be a nice entry. You just have to bug the seniors to be your mentor, and some of them are usually they're keen if you're persistent enough, and you can pick up things up quite quickly. So it doesn't need to be bio, but what we see also is a lot of clinicians are moving into research. So there's a lot of young physicians who are physician scientists or want to be physician scientists, and when they come into research, they're usually very quick to apply it. Because if you come into it as a scientist, your whole career will be focusing on a very narrow part and understand, and it will stay in the most times. It will stay in the lab in a way. If it reaches people in your lifetime, you are one of a few. Well, if you're a physician, you have an idea of what are real world problems that you experience. You're already coming in with something that your interest will come from a place of a real world problem. And then it's easier to take it out the lab and bring it into practice. So I think there's definitely a lot of space for physicians in science.
Yeah. And then a minute ago, you mentioned writing your own book. What are books that you'd recommend people check out? I'll read them. I read every book pretty much that people recommend. Including textbooks.
Well, I am an entrepreneur, so I love entrepreneurship books, and I can talk about them with you all day. There's a good popular science book. I'm actually trying to convince the writer to turn to glycomics, called The Cure. And it talks about the immune system and all the immunotherapies and their history of development, but also just how basic science started and got to that at the end of it. And on my definitely books that I like and would recommend, there's few I've read multiple times. One is Maverick, which is a Brazilian entrepreneur who pretty much turned he was a bit of a rebel. So anything that you should have done in business, he did it the other way and create a very cool company culture and things which are actually we're doing today, we're applying in business today. But when more and more of it, not all of it, because it was quite radical, like a team of people selects their manager. There's no imposing a manager on a team. And they do this continually. They, decide if this person is going to continue to be their manager. They even select the CEO. That's what he said. He hasn't been CEO for the last 10 years. Apart from that, there's another one I really like. It's called Let It Go. It's a British entrepreneur, a lady. She founded a company in the 1960s, which was the first women programmers. They're called freelance programmers. They're, punch cards from home. All women. They coded it started from from her kitchen into a 8 billion market cap company at the end of it. A very nice personal story. I like biographies, and she doesn't leave anything. She tells her full story, from ending up in a mental institute for a breakdown, to her autistic son, to all of the good and bad that she's gone through as an entrepreneur. So that's one I would recommend, and I can go on, but I don't think you need the whole list of entrepreneurship books or biographies of Oh,
I'm a big fan of biographies. I'm reading a kind of a biography and kind of not. It's about the civil rights. Actually, you can see it on my screen, right? I gotta get the mirror right there. It's about like the civil rights movement in America, and it kind of follows Dr. King. It's pretty cool. But so I'm a big fan. I'm going to check those out. I think the first programmer was a woman as well. Like for her name, but I think the first programmer, the first like computer programmer, was a woman, which is pretty cool. For people who want to stay up to date with what you're working on, is the website? Is there a newsletter? What would be the best way? Like the best one way to stay up to date with everything you're doing?
We have a space in the website called GlycanHub, which is a blog, a podcast, and a newsletter. So it's the podcast is probably the best part of it. We interviewed the top glycobiologists in the field, and they're probably all the Glycan podcasts you're going to find when you go into search. So if you type in Glycan, it's mainly going to be that and a few other interviews. So I would highly recommend it. We try to get their language down to something that more people can understand, but it is a technical field, so build up an appetite.
Yeah. Well, if you ever have a problem riding too high, because I was once working with someone who had an advanced degree, and they kept trying to write for like the 5th grade to 8th grade level, which I think is what most people read at, and they could not write lower than graduate level. Like we had like one of those analysis things. They could not write lower than the graduate level, which is really funny to me. But you can get ChatGPT, you can get like open source AI tools to translate it into a not lower, but like a different grade level in terms of reading comprehension. But so just as an idea, you let me know if it works. But conversely, anyone listening in who's reading something that's very complex and they're not understanding it, just take that and like put it into like a ChatGPT type of thing and have them translate it into what you like. One thing I do is I give them a paragraph that I wrote, and I say, take my paragraph, take this thing that I'm trying to understand, and translate it into my language. So it's very customized. But I want to thank you for coming on the show, for everyone listening in, for talking about something that really is relatively unknown. Like people don't know about this, but I think there is a unique and big opportunity to help a lot of people with it. So thanks for coming on, and thanks for sharing your knowledge with us.
I appreciate it. Thank you for having me on. I enjoyed the conversation.